Now, let me show you some examples on how to find big O of certain functions. And the first type of functions we are going to explore will be of type polynomials. This is now how a polynomial is written mathematically. It consists of terms, and each term has a power of x multiplied by a coefficient. The term with the maximum power represents the degree. So this is the maximum power, and the maximum power is n. So we say that this polynomial of degree n, so therefore a of n should not be equal to 0, otherwise the degree of the polynomial will be decreased to n minus 1. For the basic definition, it consists of two functions and two witnesses. F of x is one of them, so we need to find g of x, appropriate g of x, and two witnesses. To apply the basic definition on f of x, we are going to use two calculations or two methods. One is using ad hoc calculations, and the other one is using general procedure. Ad hoc, it means the steps or the calculations we do differs from one polynomial to another one. But for the general procedure, we apply the same step over all polynomials. These steps are obtained from the understanding of the ad hoc calculations. And I will show you this in a moment. So the first example that we need to solve will be find a big O, which is an upper bound of f of x as a polynomial of degree 4. Here is our example. Find big O, which is upper bound of a polynomial function f of x. First, we need to find the degree of this polynomial. So we write degree equal 4. And how did we find this number? Look at these terms. The maximum power is 4, so the degree is 4. Also, we would like to find the dominant term. The term that when x becomes very big, it controls the equation. It is x raised to power 4 because the degree is 4. So the term that is greater than all other terms is this term, and it's called dominant term. Now let us see the relationship between each of the other terms related to the dominant terms. Let us start with x squared, 2x squared. You know that for x greater than 1, you know that x is less than x raised to power 4. Now, if you multiply both sides by 2, then you can say that 2x squared is always less than 2x raised to power 4. Now, let's go for the other term, which is 7x. And you know that x is always less than or equal to x raised to power 4, assuming that x is positive. Then you can multiply both sides by 7. So 7x is less than or equal to 7x raised to power 4. Now for the constant 4, you know that for x greater than 1, then 1 is less than or equal to x raised to power 4. Multiply both sides by 4. So here you will have 4, and here you will have 4. So 4 is less than or equal to 4x raised to power 4. Now the definition for big O, it says f of x less than or equal to c multiplied by g of x for all x greater than k. And here we have three missing parameters, c, g of x, and k. So let us start from the left-hand side of the polynomial by writing the polynomial. It is 3x raised to power 4 minus 2x squared plus 7x minus 4. Now you know that negative number minus 2 is always less than 2, which is the positive number. So any negative number is smaller than its corresponding positive number. So what I'm going to do on the right-hand side, I'm going to say that the left-hand side equation is always less than or equal to, I'm going just to copy the dominant term, which is 3x raised to power 4. And since negative number minus 2 is always less than 2, so I'm going to change this term into positive 2x raised to power 2. And 7x is already positive, and minus 4, I'm going to write it plus 4. So in the first step, all of the terms or all of the coefficients that are negative will be converted into positive. But when you do that, these two equations are not equal. Definitely the one on the right hand side will be greater than the one on the left. Why? Because the polynomial on the left hand side has some negative numbers, and when you change it into positive, then you are increasing the value of this polynomial, so it is less than the polynomial on the right hand side. Also, from this relationship between the dominant term and the others, what I'm going to do, I'm going to keep 3x raised to power 4, but since 2x squared is less than 2x raised to power 4, then I'm going to replace 2x raised to power 2 by 2x raised to power 4, but I need to change the inequality into less than. Why? Because if you compare these two, they are equal. But these two are not equal. This part is less than this part, so this equation is less than or equal to this equation. Continue, plus 7x raised to power 4 plus 4x raised to power 4. So what I have done here, I have replaced all other terms by the dominant terms and keeping the coefficients of these terms positive. Now, since all the terms of this polynomial have the same term, x raised to power 4, so just simply add the coefficients, and this equation is equal to, we can keep less than or equal to, doesn't matter. So this will be x raised to power 4, and we add 3 plus 2 is 5, 5 plus 7 is a 12, 12 plus 4 is 16, so we write it here 16. And this relation is true as long as x is greater than 1. And this is, we started with from here. Because you replace 2x squared by 2x raised to power 4 whenever x is greater than 1. So this is why we have x greater than 1. Now let us arrange the equation. So we say that f of x, which is this equation, is less than or equal to 16 multiplied by x raised to power 4 for all x greater than 1. And from here we can say that g of x is equal to x raised to power 4, c is equal to 16, which is this one, and k is equal to 1, which is equal to this one. And this proves that f of x belongs to big O of x raised to power 4. For the ad hoc calculations of this example, they are summarized here. For x greater than 1, we kept the dominant term and we replaced every negative number by its corresponding positive number, and every term other than the dominant term were replaced by the dominant term. And then we added the coefficients for the resulted equation as the value of c. Now we can do other ad hoc calculations. So we will leave the dominant term as it is, but every other term is replaced by positive x raised to power 4. If the term is negative, then there is no need to change that x is greater than 1. But if you have other than negative number, for example, 7x. So when we replace 7x by x raised to power 4, then we have to solve this inequality to get the value of x as an interval. By solving this inequality, we will find that x should be greater than the square of 3/7, and this is almost like 1.9. So therefore, we say that x should be greater than 2, and accordingly, we have to change x greater than 1 into x greater than 2. Since we need only one pair of witnesses, we can consider the ad hoc calculations in this example as a guideline that we can apply it on any polynomial. This guideline can be listed in steps as follows. First, to find the value of g of x, assume it is equal to the power of x of the dominant term. Next, to find the witnesses, let k equal to 1, so assume it's equal to 1, and the value of c will be equal to the addition of the absolute values of the coefficients of the polynomial. So here is an example. We need to find big O of this polynomial. This polynomial is of degree 5, and the dominant term is 2x raised to power 5. So in step number 1, it says g of x will be the dominant term, the power of x of the dominant term. So g of x will be equal to x raised to power 5, and k is equal to 1. And for the constant c, you add the coefficients of the polynomial, but take the absolute value. So 2 plus 6 plus 3 plus 4 plus 2, which is equal to 17.